A step may locate the ring axially, a groove may receive a secondary seal or mating feature, and a notch may control orientation or rotation. Another pump, valve, or housing can require a different face width, shoulder, recess, or locking detail while using the same ceramic material family. Dynamic sealing places repeated sliding contact on the face, while process particles can add abrasive action. The specified zirconia range is approximately 1150 to 1300 HV10, and an independent 3 Y-TZP reference grade is about 1300 HV 0.3. High hardness helps resist scoring and gradual geometry loss, but wear still depends on the mating face, fluid film, speed, load, contamination, and operating temperature. A seal ring also experiences handling loads, assembly stress, pressure distortion, and occasional edge contact. Yttrium-stabilized zirconia gains fracture resistance through stress-assisted transformation near a crack tip. The product range gives 8 to 10 megapascal root meters in fracture toughness, while the independent reference grade is 10. This toughness supports detailed annular geometry, but sharp corners, impact insertion, and uneven clamping can still damage the part. The ring must also limit elastic distortion under hydraulic and spring loading. A representative 3 Y-TZP elastic modulus is about 205 gigapascals. High stiffness helps the sealing face retain its intended shape, yet actual distortion depends on face width, ring thickness, recess depth, support geometry, temperature gradient, and how evenly the ring is mounted in its holder. In a mechanical face seal, one ring rotates and the other remains stationary. Their primary sealing surfaces are lapped extremely flat so the closing forces can create a stable interface around the circumference. Industry guidance describes typical face flatness in only 2 to 3 helium light bands, about 0.8 of a micrometer. Surface roughness and face flatness are different measurements, and both must be specified for the actual sealing zone. The faces are not intended to run as two dry solids pressed together at operating speed. A thin film of clean fluid separates and lubricates them, carrying away heat while limiting visible leakage. The working gap can be as little as 1 micrometer. Spring force and hydraulic pressure apply closing force to the seal faces, while pressure in the fluid film acts in the opposite direction. Excessive closing load increases frictional heat and wear. Insufficient load allows the gap to open and leakage to rise. Alignment, face runout, holder distortion, and ring support therefore belong to the same problem as material selection. Zirconia cannot correct an assembly that loads the face unevenly. Seal ring dimensions are determined by the shaft, seal chamber, rotating or stationary holder, and the required contact band. Available zirconia examples span outer diameters from 10 to 115 millimeters. Drawing-based options extend to approximately 1 to 150 millimeters in outer diameter, 0.5 to 140 millimeters in inner diameter, and 1 to 50 millimeters in height. A valid drawing has to define more than 3 overall dimensions. The sealing face width, face profile, flatness or contour requirement, step height, groove section, chamfers, notches, mounting fit, and the relationship between functional surfaces all influence installation and operation. Custom features should be tied to a clear purpose, because unnecessary thin sections or sharp transitions can increase machining cost and local stress. In a chemical process pump, the ceramic ring can serve as one hard face within the mechanical seal when the complete design confirms that role. One member rotates with the shaft and the other remains stationary. Their annular faces must remain flat and aligned so the closing load is distributed around the circumference rather than concentrated at one edge. During rotation, a microscopic fluid film separates the faces, reduces direct contact, and removes frictional heat. The film must be clean enough to protect the polished surfaces and thin enough to limit leakage. Dry running, vapor formation, abrasive particles, or interrupted cooling can destabilize this interface even when the ceramic itself remains hard and chemically durable. Zirconia is considered when toughness, wear resistance, and corrosion behavior are valuable at the seal interface. Final suitability still depends on the fluid chemistry, solids, temperature, pressure, speed, mating face material, and lubrication regime. At operating speed, a ring only millimeters thick becomes the boundary between controlled flow and an unintended leak path.